Okay, today we're going to be solving radical equations, and our goal is to solve problems like problem number 1. How do you undo a radical? What's up? Yeah, you times it by the same radical. In this particular case, this is a square root. So in order to undo it, we have to square both sides. Square this up, square this up. Because you are multiplying the square root by itself, all you get is the stuff inside. 5 squared is 25, and then you just solve for x. Add 3, add 3. 2x equals 28. You can't just do it from the beginning because it's locked underneath the square root. And suppose you tried to add 3 to both sides in the beginning, then you would get the square root of 2x equals 8. It wouldn't make sense. So always, always, always when you do these problems, you have to essentially release the stuff underneath the square root first. Okay. So finally over here, we're going to divide both sides by 2. And x is going to be equal to 14. Now you cannot stop here at all. And I'll show you why. Because square roots have what's called restricted domains. So you have to do the most annoying thing ever. The most annoying thing ever at the end of the problem, which is, you have to check. You always, 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 always have to check. In fact, let's remind ourselves of this by drawing a bomb, because this will blow up in your face if you forget to do it. Always check your answers. Okay, so let's show the check exactly how it should look. So here we go. You take your answer, 14, and you plug it back into the original equation. So that's 2 times 14 minus 3 equals 5. Well, we can do this business in our calculator. 2 times 14 is 28, and 28 minus 3 is 25. And is the square root of 25 5? Yeah. So we're good to go. Check. Okay, problem number 2. Problem number 2. Problem number 2 is a little different than problem number 1, only in that there's this little extra 4 being added onto the radical. So here's what you have to do. Every single time this takes place, step 1 is isolate the radical. Isolate the radical. Isolate the radical. Make it look like the first question that we did. How would you isolate the radical? Subtract the 4. And I'm going to do it in a little weird way because I don't feel like writing the problem over. So we're going to subtract 4 from both sides. This and this cancel away. We get square root of 1 minus 3x equals 8. And now it's just like the other problem, right? What do we do? Square it up. Square it up. Yeah, piece of cake. So we're going to square up both sides. Square it up. Square it up. 1 minus 3x equals 64. Subtract 1, subtract 1. Negative 3x equals 63. Yep. Divide by negative 3. Divide by negative 3. X equals negative 21. Always, 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 what do we have to do when we solve radical equations? We always have to check. Please don't forget to do that. So over here, we're going to include our check. We're going to take the original problem. We're just going to plug in the answer that we got. Square root of 1 minus 3 times negative 21 equals 12. 3 times negative 21 is negative 63. 1 minus negative 63 is 64. Yep. Oh, I'm saying like, oh, I understand. You multiplied negative 3 times negative 21. Yeah. So this is just, 4 plus 8 equals 12. And I'm going to stop right here. This is good enough for a check. Yeah, we are good to go. Let's put a square around our answer over here, indicating that we're accepting it. And that's it. Okay, problem number 3. Problem number 3, a little different than problem number 2 in the fact that it's got a cubed root. And the way that you undo a cubed root is by simply cubing both sides. Really easy idea. Cube both sides. That's the first step in doing these problems. So now we got 4 minus 2x equals negative 2 cubed. That's negative 2 times negative 2 times negative 2, which is negative 8. And so we subtract 4 and we solve for x. And we get negative 2x equals negative 12. Divide by negative 2, divide by negative 2. X equals 6. Same thing with square roots, or any radical equation for that matter. After you get done and you solve, you find out what x is. What do you always have to do? The most annoying thing ever, just like the sound of my voice, always got to check. Whoops. Let's do our. Yep, this is the last topic that we're learning before our test. Check. And so we're going to take our original equation, we're going to plug our answer back in. 4 minus 2 times 6 equals negative 2. The cubed root of 2 times 6 is 12, 4 minus 12 is negative 8. Is the cubed root of negative 8 negative 2? Yeah, absolutely. The cubed root, something multiplied by itself 3 times is negative 8. What's that something? It's negative 2. So we're good, done, good to go. Let's put a box around our answer to signify that we're accepting it, even though that's a messed up box. Hit record. All right, guys, last problem of the day. The hardest and most difficult of the problems we're going to look at today. Same steps as before. Isolate the radical first. So we're going to subtract 1. Subtract 1. These cancel away. X minus 1 equals square root of 15 minus 7x. Always when you do these problems, isolate the radical. Ooh, I messed up. I messed up. My bad. Okay, now we've got a square root on the right side. How do you undo the square root? Okay, so we're going to square up both sides. Check this out. Square it up. Square it up. Oh, this is going to be a lot of work. X minus 1 squared, that's the same thing as saying x minus 1 times x minus 1. And you know what that means. Oh, we're going to have to FOIL it. Yep. All right. So here we go. Now, some people, if you're really good, can multiply that out in your head. Let's see. Let's see if you're right. So here we go. For those of you that guessed, x squared minus 2x plus 1 equals this business. Uh-oh. We've seen problems like this before. Of course, yep, you got to set it equal to 0, and we got to solve. So we're going to add 7x to each side. We're going to subtract 15 from each side. X squared plus 5x minus 14 equals 0. We've seen stuff like this before. It's like all of a sudden, all the math you ever learned is suddenly coming together. What do you do now? Yes! We're going to have to factor. I love factoring. It's my favorite thing. Factoring. Find two numbers. I found two numbers that multiplied to be negative 14, and they added up to be positive 5. And once you factor and set it equal to 0, then here's what we're going to do. We're going to solve this particular equation. X minus 2 equals 0. Add 2, add 2. So one possible answer is the fact that x could equal 2. The other possible answer to this problem is that x could equal negative 7. And I got that by subtracting 7 from both sides. We're done. All right, here we go. Last part of the problem. So we found that x minus 7 is a possible answer, and x equal to negative 7 is a possible answer, and x equal to negative 2 is an answer, possible answer. And every time you have a radical equation and you solve it, you always have to check it. So here we go. We're going to plug in negative 7 first into our original problem. So negative 7 equals 1 plus, let's see, 15 minus negative 49 is, minus negative 49 is the same thing as positive 49, right? Because two negatives negate each other. Okay, so it's 64. Yeah, 64. And so we got negative 7 equals 1 plus 8. Is that true? Nope. Nope. And so we have to do to negative 7 what every girl in high school always did to me. We have to reject it. That's okay. That's okay. It's not that bad. All right. All right. All right. All right. It's nothing that everybody doesn't know already. Okay. So we have to check the other answer. We have to check the other answer, and that's 2. So we're going to plug 2 in. 2 equals 1 plus square root of 15 minus 7 times 2. Let's just make sure it works. 2 equals 1 plus the square root of 15 minus 14 is 1. Does 2 equal 1 plus 1? Yeah. Yep. Yes. That's awesome. There is an answer to this problem, and it is just 2.